Welcome to the lecture series on fluid power system. In this lecture video, we will see the construction of fluid power systems. Based on the construction aspect, we can see the differences in hydraulic components and the pneumatic components. Then probably while designing a circuit, how we can go for using the different symbols in hydraulics and different symbols in the pneumatics to generate the circuits. So first we'll start with the construction of the various components in hydraulics. Then we'll move on to the various components probably used in the pneumatics. When you take the any fluid power systems, first we'll start with the construction of the power generation unit, how it differs based on its construction. So when we take the hydraulic system, probably we call it as a power pack, where we have three major elements like pump, tank and the relief valve, probably constituting it as a power pack, so that we can has it being used in the hydraulic applications. So in addition to that, inside the tank we can have a filter as well as strainer being used. Apart from that, it is must to provide a relief valve in all the hydraulic power packs, because of the high pressure requirement, yeah, a relief valve is must. When compared to the construction of a power generating unit, probably in the pneumatics we have a compressor with a storage tank, where we can store the compressed air and we can use it for our applications. Apart from the compressed air and storage tank, we can also have additional supporting components like dryers, then moisture separators are being used to purify the air. So this being additionally used in the power generating unit of pneumatics. Next, coming to the construction of valves and actuators for the hydraulics and pneumatics, it's almost similar. So when you take a direction control valve being used in the hydraulics and as well as in pneumatics, both are similar in construction, but only thing is the size will be different. So for hydraulics, it will be it will be a bigger in size. For us in pneumatics, probably the size will be a smaller one. Then coming to the cylinder, the same applicable. So for a hydraulic cylinder, it will be of a huge size. For pneumatics, it will be a smaller size. So why this size difference is because based on the pressure being used. For example, in pneumatic applications, we can go up to a maximum pressure of 10 bar. So that is why the size of the pneumatic cylinder is very small. Whereas in hydraulics, we'll go up to a pressure of more than 400 to 700 bar. So the high pressure requirement requires a huge construction of the cylinders as well as the direction control valves. So that is why the hydraulic components are bigger in size and also required a safety system along with the other components. Then coming to the transmission of pressure using pipes, hoses and connectors, we can have the hydraulic components probably is made of a steel and the steel reinforced pipes and tubes, where we can have a high pressure being what you call maintained inside that. So normally we can have this fiber reinforced pipes or flexible pipes being used. Apart from that, we can go for steel pipes and steel tubes also. Whereas in case of pneumatics, probably we'll use a polyurethane tubes or hose with a diameter of 4, 6, 8 and 10. So maximum we can have a 10 bar being passed on to it, so that it will be more than enough to be being used. Then in case of the connection aspect, we can have a lot of quick fit connectors available. We can easily connect the pneumatic systems using that. Whereas in case of hydraulic systems, we need rigid connections. We have to put a lot of bolts and nuts along with the couplings being used to connect the connectors. So the safety aspect, the hydraulics required a huge concern, whereas pneumatics we can easily make the systems being formed. Then coming to the piping selection, it is are purely based on the stress that is being developed on the pipes. For that, we have to calculate the burst pressure. So burst pressure is 2 times the tensile stress multiplied by the stress developing on the pipes, then divided by the diameter of the pipe. So working pressure should be calculated based on the maximum burst pressure divided by the factor of safety. For example, if you are operating in the pressure of 0 to 70 bar, a minimum factor of safety should be 2. Then in case of 70 to 180 bar, we need a factor of safety of 3 to 4. Then in case of pressure ranges from 180 to 250 bar, the factor of safety should be 4 and above. So based on the increase in pressure ranges, we got to increase the factor of safety also, because the systems being that means developed requires a higher safety protocols that is to be followed if the pressure is more than 300 bar. Then in case of pressure more than 500 or 600 bar, the factor of safety is again increased to even 6 to 10. so that the higher safety level is being maintained in all hydraulic systems. The piping selection is purely for the hydraulic applications, whereas for pneumatics not much required, because the maximum pressure that is being generated is only 10 bar. Then coming to the calculation of pressure, so as based on the Pascal's law, we can easily calculate the pressure for an application like a service station, this car service station, where lifting of a car is a mandatory task that is being done. So for this, you can see that the hydraulic piston has a 250 millimeter diameter. Then it has a task of lifting a 13,300 Newton force. So for this, we have to find the oil pressure required to lift this automobile. Say approximately it is 13 kilonewton automobile that is being lifted on. So for this, we can easily use the Pascal's law to calculate the pressure required to lift this automobile. Similarly, when you go for the comparison of pneumatics and hydraulic components, probably you can see that hydraulic controls, probably hydraulic components produces extremely large force as 300 bar, 500 bar pressure. So we need to provide a safety to all the systems. Then it requires a heavy duty components. Then obviously it is a silent and smooth movement, you can get it in the hydraulic. Whereas in pneumatic it is absolutely low power with the 10 bar pressure. Then it is clean and quick and fast response. Then overload safety will be always there. Then comparing the cost wise aspect of hydraulic and pneumatic systems are inexpensive of, or it's very low cost compared to the hydraulics. Then coming to the system building, probably with hydraulic applications, there are some mandatory components that is required in the hydraulic systems. So for example, the power pack is a mandatory one, where we have a pump, motor along with relief valve and filter is there along with the tank. Then after that, we can have these various stages. We have the control components and we have the actuators. So the control components, probably we have flow control valve, direction control valve and pressure control valve. Then we can also have some auxiliary units like accumulators also being used. Then coming to the actuator part, we can have either hydraulic cylinder or we can have a hydraulic motor is being used in the end application. So in this, we can see a block diagram or the picture of how typically a hydraulic application is being designed and developed. Then coming to the components required for a hydraulic system, so the hydraulic power pack, probably we call it as a reservoir. Then we can have a pump, motor along with relief valve, we call it as a hydraulic power pack. Apart from that, we can have the actuators, either hydraulic cylinder or motor is being used to produce either linear or rotary movement. Then we can have the control components, pressure control valve, direction control valve and flow control valve is being used. Then ancillary components like accumulators, intensifiers, then other moisture separators are also being used in addition to the regularly required components for the hydraulic system. Then coming to the in case if I am designing a new hydraulic system, first I'll start with making a block diagram in which the mandatory components are being drawn as a blocks, and we can see that how a system is going to function. As already discussed in the previous session, we know that hydraulic system is a closed loop system. The flow starts from the tank and it will ended, the return flow also comes to the tank. So we'll go with the starting from tank, then we'll go to filter or strainer. Then we have a pump coupled with motor. Then we have a pressure regulator, and we have the control component, that is direction control valve, where it will operate the actuator in based on the requirement. Then coming to the design of a circuit, probably for a hydraulic application, we have to use some the standard ANSI or ISO symbols that is already designated for the various components. So we have to select the component symbols and we have to appropriately build the circuit. Say for example, reservoir, we have a symbol, filter, pump, motor, then direction control valve, cylinder. All the components there will be a designated ANSI and ISO symbol is being there, so that we can select it from the library and we can build the circuits. So this is what the circuit building probably with the hydraulic system. Then coming to the correlation of the real hydraulic system with the hydraulic component symbols, we can correlate like this. Say for example, you have a tank here, so that it is being matched with the hydraulic symbol, that is a tank symbol. Similarly, we have a strainer there, so we have a strainer that is being correlated with the strainer symbol. Then we have a pump fitted with the motor, for that we can match it with the hydraulic pump symbol. Then we have a pressure relief valve, that is integral part of the hydraulic power pack, which is present inside, probably it is matched with the pressure relief valve. Then we have a control component, that is direction control valve. So for that direction control valve, we can have the equivalent direction control valve symbol that is being mapped. Then we have an actuator that is a hydraulic actuator, that we can map it with the hydraulic actuator symbol. Then in all hydraulic applications, we have to use the triangle which is being shaded. So in case of pneumatics, the triangle will not be get shaded. So that is what the basic difference between the circuit building exercise with the hydraulic and pneumatic applications. Then in case of pneumatics, the entire list of components may vary, because in pneumatic applications we'll start with the air compressor and storage tank. Then we have a lot of air conditioning components are being required, are being used, like filter, air dryer, oil water separator, then other filters. Then probably you can have some kind of a heating, there's heater or the temperature reducing components also being used. Apart from that, we can have the FRL unit which is being used in all end applications, where we can go for filtration of compressed air, regulation of pressure, then adding some lubricant to the compressed air. So after that, we can have the end applications like air tools, then we can have the sanding gun, probably we have the painting gun, or we can have the pneumatic cylinders are being used, or we can have some kind of a painting guns being used in the pneumatic applications. So this is what this typical pneumatic system that is being employed in any applications. Then coming to the block, probably the design of a pneumatic system using blocks, we can start from compressor, where the air from atmosphere is taken through air filter and is being compressed to a maximum of 10 bar. Then it is being stored in the storage tank. Then it is being distributed to through various control components like direction control valve, flow control valve, and it finally reaches the actuator, where we can do some lifting, lowering, then some kind of an operations, rotational, clockwise, counterclockwise operations, and we can perform the required actions in the pneumatic applications. Then coming to the mapping of the real components with the circuit symbols, so we can have the air compressor which is being mapped with the pneumatic power source. Then we have a storage tank that is being mapped. Then we have the FRL unit probably mapped with the FRL unit symbol. Then we can have a 3 by 2 DCV mapped with the 3 by 2 DCV symbol. Similarly, we are using a 5 by 2 DCV that can be mapped to a 5 by 2 DCV symbol. Then we have a pneumatic actuator that is being mapped to a pneumatic actuator. So like this, we can easily draw the pneumatic circuit for the same components being used in the pneumatic application. Then coming to the applications of pneumatics, earlier we have seen the application of hydraulics. Here we can see that the pneumatics find a larger application in the industries. We can see with a small video. So we'll see how a pneumatics is being used. So we have this pneumatics, probably have
This
some
video will
industries,
describe how industrial pneumatics
industries like genetics, Parker Hannifin, Rexroth, then you have some kind of a Festo, then you can have the SMC, where they are involved in producing the pneumatic system. In this video, we can see that how compressed air that is being produced by the compressor is being used to operate a pneumatic cylinder.
systems work. These 5 types of components represent the most common elements used in these systems. The ultimate goal of this entire collection of components, in most cases, is to create motion that will do some type of work in an industrial setting. Pneumatics is one of the most widely used technologies. Let's not clog
So
up
in
the
this,
moving
you can see
compressor.
that the compressed
This
air
adjustment
that
has
is
an
being
impact
generated
on
will
how
flow
much
to
force the
the
system
FRL unit,
generates.
where it
Higher
will be
pressure
filtered,
allows the
regulated, and
actuator to put
lubricated.
out more force.
Then after that, it will move on to the other control components.
Around
Then
them
finally
and
it reaches
proceed
the
to one of the
direction control
working
valve,
ports.
and it will reach the
The
cylinder,
valve is to
where
cause
the cylinder
motion
will
in different
extend and
directions.
retract based on
Parker
the
makes a wide
direction
variety of
control valve that is
actuators,
actuated by
or
the solenoid
cylinders
valve,
as they are also commonly. This reverse
so
motion
that we
is
can have
typically
a
referred
movement in the
to
cylinder
as
like this.
retracting. For
So
this
we can have
actuator
a
to
front
retract,
movement
the
or
air
rear,
that is already
that is
filling the
reversal
cylinder
movement
needs to
probably
go
obtained in
somewhere,
the
which is commonly
pneumatic
referred
cylinder.
to as exhausting. The exhaust air
Then in pneumatics, it is a open loop system. We can have the air being used is exhausted to the atmosphere by a silencer being fitted on the solenoid valve. That is a direction control valve. We have the silencers being fitted. It will be exhausted to the atmosphere. Then this system is controlled by a PLC, since we have used the solenoid valve for operating the pneumatic cylinder. Then coming to the differences, probably as already told, the major difference is the triangle that is being used inside the any symbol For example, in case of hydraulics, we have to draw the triangle with shaded. Then in case of pneumatics, it is triangle without shaded. So that is what the basic difference we have in the hydraulics and pneumatics. Apart from that, almost the same symbol is being used for hydraulic pump as well as for the compressor. Similarly, for pneumatics and hydraulics, in the aspect of control components like the direction control valve or flow control valve, the same symbol is being used. Whereas the triangle, if it is shaded, it is hydraulic DCV. The triangle, if it is not shaded, it is a pneumatic DCV. Then similarly for the hydraulic cylinder, pneumatic cylinder, as well as for the hydraulic filter and the pneumatic filter, so that we can easily develop a new circuit using the hydraulic component symbols as well as pneumatic component symbols for the pneumatic circuit diagram. So then finally, if for example, in case we are building a circuit, we must able to identify the symbols which is being used. For example, uh, if I am having a hydraulic circuit being developed, uh, you have a tank is being used. So that is the first one. Second is a filter or strainer. Third one is it is a unidirectional pump. Then fourth one is a pressure relief valve. Fifth one is a 3 by 2 DCV. Sixth one is a flow control valve. Seventh one is a 4 by 3 lever operated DCV. Then eighth one is a cylinder. So like this, whenever we do a circuit designing in a pneumatic or hydraulic, we have to identify the appropriate symbols with the proper technical names. Then similarly, if any circuit is given there, our objective is to find out what are the symbols being used, what is the purpose of each symbol. Here you can see that this one is a motor, then you have a pump, then you have a filter or strainer, then you can have a pressure relief valve, then you have a unloading valve, we can have a DCV, then we can have a flow control valve with the check valve, then finally we have the double acting cylinder. So like this, for any circuits, we must be in a position to identify the symbols being used. So any circuit we can design and we can develop, and we must be in a position to identify all the component symbols being used. So these circuits probably we can design using any softwares available like Automation Studio, Festo, Numasim, Hydraulics, Hydrosim, or any other, even MATLABs also we can create a circuits using the appropriate tools. Then similarly, in pneumatic circuits, you can have this compressor symbol, air receiver symbol, FRL unit symbol. Then all direction control valves, we can have a silencer being used. We can able to find it. Then we have a single acting cylinder. So we have double acting cylinder being used in hydraulics, whereas single acting cylinder is also being used in the pneumatics. Normally for pneumatics only single acting cylinders being used. Hydraulic normally it is double acting cylinders being used. So similarly in pneumatics we can able to identify all the symbols. So for any circuits, we can uh, build and identify and as well as define the symbols being used. So not only the pneumatic circuits or hydraulic circuits we can develop, we can also combine electrical controls, PLCs and HMIs probably while designing hydraulic circuits and pneumatic circuits, that we call as electro hydraulic circuit or electro pneumatic circuits. So we have these features available in the softwares like Automation Studio, where we can easily design and develop any combinational circuits. Say for example, PLC operated electro pneumatic circuit or PLC operated electro hydraulic circuit. So these are the features of the software. So while going for the circuit designing, we will go for hydraulic, proportional hydraulic, pneumatic, proportional pneumatic, and while combining electrical, we have the two standards being followed, JIC and IEC, where we can combine hydraulic with electrical, we can combine pneumatic with electrical. Even when we go for using some PLCs, we can have some standard PLCs like Allen Bradley, Siemens, and other types of PLCs being supported. We can even create ladder logic diagrams using PLC. Then even we can go for using some HMI and control panels also being used in the electropneumatic circuits. So normally we'll follow ANSI standards, that is American National Institute standards, or even we can go with the ISO standards of symbols being used for circuit design and development. So these are the various components present inside hydraulic module, and these are the component symbols present inside the pneumatic module. Then coming to the combinations, we can have some electrical symbols like 12 volt, 24 volt, 0 volt, then normally open, normally closed are being used. Similarly, some solenoid valve symbols are being used in the electropneumatic circuits. Even when you go for integrating some HMI components, we can have the symbols available in the software. We can use it. So we can have these circuits being developed and we can see the simulation of the circuits. So once you create a circuit, after that we can test the circuits using this simulation. We can easily build the circuit and we can see that how a circuit is functioning using this software. So like this, we can build the circuit using the software and we can test the circuits. Pneumatic circuits, hydraulic circuits, anything we can build and we can test it. So even the complex circuits also we can build using the software and we can test it for its working before the real implementation of the circuits. Then finally, when coming to the pneumatics and hydraulic components and its applications, the safety precautions are highly essential. So for pneumatics, the pressure is maximum of 10 bar, but the safe operating pressure is 2.5 for 2.5 bar to up to a maximum of 5 bar is more than enough. Since all the components will operate with a minimum pressure of 3 bar, maximum 10 bar there is no requirement, so we can operate with the pressure of 5 bar for pneumatics. For hydraulics, obviously it is danger even we are going to a pressure of more than 300 to 500 bar. Say for example, there are some dangers associated with the high pressure oil jet, like oil burns, crushing, cutting, then injection is required probably on the hand. Say for example, of 180 bar pressure jet leaking, we can have the injury like this on the human hand, so that has to be taken care. So for hydraulics, obviously the dangers are high. We have to provide suitable safety systems to prevent these kind of accidents. Some videos are there that we can see it later on regarding the hydraulic dangers and the pneumatic dangers. So with this, probably I'll conclude that the hydraulic and pneumatic systems are probably used in the industrial applications based on the power and load requirement. For small and medium load applications, we'll prefer pneumatics. For high and heavy load applications, we'll go for hydraulics. Then in case of the advantages available with the electrical, we can combine electrical with pneumatics as well as electrical with hydraulics, and we can have the combination circuits are being developed and used in the semi automation and fully automated systems in the industries. Thank you.